So we're going to be doing a riser detail and a standpipe diagram in 3D using SketchUp. And so right now we're looking at the job we're going to be doing in 2D in IntelliCAD, and the water's coming into this hotel in the basement right here, and then there's a double check, and then we got a couple of risers here, and one of them is feeding this floor, and then one's feeding the standpipe. We're going to be drawing all of that in SketchUp, and I've been doing details like this in SketchUp for a while, and so in this type of situation, what I generally do is just start with one that I did before, and then we'll modify it. So I have already started doing that here. I just had an apartment building with the standpipe in it, and this is that standpipe system. And so I'm just going to, this has all the pieces that we need in here. The only thing that's missing is, we were just looking at that drawing of the basement. There was a double check valve in there. And so we need to bring in one of those. It'll go here. And so we're just gonna start moving stuff around and make this thing work. So one of the things that I actually did, I got started a little bit before we started recording. This existing one that I saved just had this slab with these pieces. And this is for, it was drawn as if it was on the main floor of a building with the pipes buried 3 feet underground coming in. But the hotel that we're working on, it actually has a basement. So the underground pipes would not be way down here. They're going to be up here at this level. And so I just added in this mocked up basement wall that I have drawn with some soil behind it. And so we're going to have, the wall was from a 13R system with a 2-inch underground that was coming in right here. But we're going to have a 4-inch underground. So I just basically, I started with this existing 4-inch riser and standpipe. And then I cut and paste this basement wall and dirt here from another job that was similar. And I'm just gonna basically make them work now together and modify it from there. So we're gonna get rid of this hole here. This is a group, it looks like. So I'm gonna edit the group, go in and delete a circle, and then click out of there. And I don't know if I'm gonna be able to continue to be as continuously flowing with my thoughts here as I'm working. May have to be some more editing going on.
I could go in with some little humor in between.
Let me think about this. What do I need to do? All right, I need to open up my other, I'm going to open a second instance of SketchUp on my other screen here. And I have
that double check valve, right?
Exactly. Yeah, I have a drawing that I used to just draw everything in, but the file got so big that it was too slow to work in. So I started, doing jobs in their own folder, or their own new file. But whenever I need pieces, I still have to go back into that original one and get them out of there. And it runs a little bit slow. These are basically pieces that I've been collecting for about 4 years. All the parts and pieces needed to draw this stuff.
Some of those pieces are already ready to go or easy to manipulate.
Yeah, it's taking a long time to open the file. Let me see. What else can I do here?
So those 2 pipes that are coming up through that floor are going to wind up coming through the wall horizontally instead of vertically, correct?
That's right. And the reason that there's 2 is because one is coming in for the supply and another one is going out to the fire department connection, so that when the fire department gets there, they can connect to it and add more water into the system with their pump.
Makes sense. Keep the sprinkling going.
Yeah.
That's what we want in a fire. So would you grab those, where those pipes go through that floor, is it all still one piece that you can just rotate?
Like this is a flange 90, that's one piece, but like this is a flange, that's one piece.
Oh, okay.
The pipe is one piece.
That's what I was wondering about. Yeah.
But that's basically like how they are in real life. All of those would be separate pieces like that.
So if you wanted to pick 3, 4, 5 of those pieces, you can just click it and hold down shift and click the other ones as well, right?
Yes. Or actually it's control. See how see how that little plus sign appears? It's really tiny, but I don't know if you can see it.
I see it.
Every time I hit control, that pops up. So if I hold down control and select something, it adds it to the set.
Okay. So in theory, you could grab that whole pipe system and just rotate it, right?
Oh, sure. We'll go rotate.
Yeah.
All right, my thing finally opened. Let me pull this over.
Okay, that's a double check valve.
That's just another riser assembly from another job. You can see these are all lined up riser assemblies. Riser details I've drawn.
A lot of them.
Just a bunch of different jobs I've drawn. Here's the one that I put that basement wall and the dirt from. I copied it from this one.
I see.
This is the same type of thing. This is actually kind of like what it'll be like right here. That's going to come in, but there'll be two. Well, actually, so what we'll do, will be just the one coming in, and then the one will go up to ground level and just stick out the wall to be for the FDC.
FDC?
Yeah, the fire department connection.
Yeah, it sounds really obvious now that I know.
Right? But not if you've never heard it, right? I mean, boy. Okay, we're getting down to the end. So down here is where all the parts and pieces. This is where I started. The first few.
Department of Correction.
There you go. But all these are the different pieces.
All the nuts and bolts, huh?
Yeah, like these are just some sort of, it's like a head nipple. These are saddles. So those flanges we were looking at earlier.
Connectors.
This is expansion tank. Oh, these are
hub connectors.
These are grooved connectors. I don't know. They might be. Let me see if I click on it. Yeah, it's just a 3-inch coupling. What's this? There's a Victaulic check valve.
And these are, you've collected these from other people's websites and.
Well, like those right there, those Victaulic has a lot of their parts. A lot of this stuff is Victaulic, but not everything. There's a mix of just stuff that I needed. I've got this is a Watts 007 check valve that's off of their website. This is an Ames Colt double check. This is the one we're looking for right here, 4-inch.
Fantastic. So that's also what's known as a backflow device, correct?
Yeah, a backflow preventer or a double check valve because there's 2 check valves in it. And this one happens to have a meter bypass. The hotel that we're doing won't have that, but City of Portland, all of the places have to have that so they can make sure you're not stealing water through the sprinkler system. So I can just select this and Control C.
So that is a component?
Yes, exactly. Control V.
Like a little city.
Actually, I think if I go into it, oh, that's too bad. A lot of times they'll have it set up to where, this will just be one piece that you can easily remove, or turn off and on. That wasn't too bad.
Oh, because you're in where you don't need that meter check valve, right?
Right.
Tap it.
Oops.
Yeah.
Gotta be careful. Sometimes weird stuff can happen. I grabbed that somehow.
Oh, something happened there too.
Yeah.
Oh, somehow it's grabbing stuff through the hole, huh?
Yeah. Try this way. I'm just gonna do that. Nobody will notice. Or maybe I can just do this now. Yeah, that's good.
Even better, huh?
Yeah. All right. So if we go back to our telecad drawing, the underground's coming in and it's churning, and this is laying horizontally. Then we're coming up with a couple risers. So we're gonna have to give us some more room here.
It's gonna be coming in on the right side of the picture and then heading to our left, right? Looking at it. Again.
Just using the push-pull tool, and I just did it 5 feet. I might change it when we're done. I just wanted to make sure I had enough room. Let's see, one thing. Use these lines that are going everywhere. These are just like construction lines that don't print or anything, but I use them like guidelines, 3 feet below ground. Let's see, 8 feet. Keep hitting the wrong button. This line is centered on this riser, and so I'm trying to copy it over to the center of this one, which is exactly 2 feet, and then go over another 8 feet, which actually, now that I think about it, why don't I just go 10 feet? Control 120. Okay, I didn't go big enough. I don't know what it is, but I kind of enjoy doing this, explaining it to someone more for some reason. So
probably opens up some different brain neurons or something. So is that the distance from the wall to the center of the pipe?
That is, I got 2 of them. That's 3 feet underground. That's where the pipe is coming in, because it's 3 foot of bury. So the pipe's going to be coming through the wall right there.
And then it intersects right with that other line that I was saying that must be a certain distance from the wall, right?
Oh, right here?
Yeah, to the center of the pipe.
Yeah, it is. I don't remember, but it's just centered on these.
Oh, okay. So that's not you're not particularly concerned with exactly what that number is?
Probably should have been. It looks like it is a weird number. I was just assumed that it was right. It was already there. That's what I get for making assumptions.
Well, I mean, the application of this drawing isn't where a technician is going to look for that type of information, right? It's more of a visual depiction of how the components are put together, right? Not so much a dimensional measurement type of tool, right? The riser detail is something you look at just to see how it's supposed to look. You're not going there for scaling the size of your pipe, right?
Yeah, not really. It is really just like for the
kind of the orientation, layout, where
yeah, like for your plans examiner to know what it's supposed to look like.
Mm-hmm.
Your inspector.
That makes sense.
All right, so I think that I want to go find that one that I saw that was right.
This is all 4-inch pipe, I'd imagine, right?
The majority of the stuff that we do is 4-inch. There's, also sometimes 6-inch underground and 8-inch even sometimes on projects, but I usually try to avoid working on crazy big projects.
Yeah.
So the majority of stuff, like 4-inch is the minimum for a 13 system that's required. So
that last project we were in, all the main lines were 3 inches, so it probably breaks down, leaving the riser to 3.
That's right. Yeah, that's right.
Reducer of some type.
Yeah, like the one that we are doing right now, the riser does happen to be 4-inch, but a lot of times it will break down smaller right off the bat. In fact, I'm sure I have one right here. So this is, what is this one? This is 6-inch. And it goes down to 4-inch. I don't know. I can't remember what project that was for.
I'm guessing right above all the valves and everything, it probably then when it would reduce down to 3, right?
Yeah, like here's one. This starts out 6, goes to 4, and then up here this is 3-inch.
Right. So there must be a reducer right there at the.
Yeah, where does this one? This is a 3-inch dry pipe valve, so it looks like I did it right here. This is a 4x3 reducing coupling, but like it could have been done right here. This could have been 3-inch.
Sure.
Where's that one? This is the one that's got just what we want. I think I'm just gonna.
Oh, you're looking for the hole in the wall?
Yeah.
Okay.
I don't know though. It doesn't even. I thought there might have been a. Can't remember what you call it. This thing. There's a term for it.
Sleeve?
Yeah, sleeve. That's right. But it doesn't have one. Oops.
Yeah, they probably just leave that a PVC section when they pour the concrete around it, right?
Right. But there is, there's a specific rule in 13 about like what the gap is supposed to be and whatnot. And I just hate having to go through the trouble of having to think about that more than once.
Yeah.
So, like if I have it drawn, I just like copy that.
Either be a sleeve or a chase. Sometimes a chase is somewhere but that's more like a space in the building usually, right? That's left.
Right. Yeah, sleeve is the right word.
Specific, right, yeah.
I don't know. I guess I'm overthinking this. I just wanted to see what size hole this was. 8-inch. And that's a 4-inch flange. Okay. So I should be able to just go right here. So it's asking me for the radius. So I want 4. All right, let's see here. So I need one of these guys. So I'm gonna have to go to a flange by groove adapter to a 90, a 4-inch 90 right here. Okay. So I need this piece. I guess that's it. Here we go. I'm using, it's like X-ray mode or X-ray view to see through stuff. I don't know how you even turn the command on. I don't remember. Except for I made a hotkey for it because I use it all the time, which is Alt-X. I can't remember how you turn it on without it. It's up here somewhere. I think it's one. Oh, here it is. X-ray face stuff. But that's super handy just to be able to do that,
Yeah. When you're in that X-ray mode, how do you know what you're X-raying through? Is it going through everything?
Everything, yeah.
So it doesn't necessarily help you select things as much as just see.
Well, like when I was putting, so let me show you. Well, actually, like when I go to put this on, I won't be able to do it unless I go to X-ray mode. I'll show you here. So I'm going to find the center, which is right there, and I want to put it right on that point right there. I don't know if you can even see it, but see how there's a little tiny little dot right there?
Yeah.
That's where it needs to connect.
But why isn't there another dot at the end of that line?
Yeah.
Why is?
Because that's where you connect on this side of the coupling.
I see.
There's a little gap in between.
Yeah, in the collar, basically. Right?
Yeah, and it's, you know, sometimes when you're doing this, if you were to miss and not do it or whatever, right, like nobody would ever notice it.
Right. It's like not like they're taking exact measurements off of it.
But I can already tell my first base point wasn't set right. These pipes are kind of difficult to move around the way I have this set up. That's probably the most difficult part of this is I know different ways of doing it that work better that maybe I should just do that when I create these. But I always just figure out a way to make it work. Sometimes it's difficult to get this to land on the end point the way you want. But I always go around it in a circle, and that gets it to keep popping up at that same center point. And then when you go out there, usually it grabs it, but it can be hard to tell if you really have it right.
I see. Oh, so now you're an X-ray.
Yeah.
Got it. Because otherwise that pipe would have been covering up your view.
Yeah, and see, it wasn't quite right. I do need to develop a better system for this part of it. This is the worst part of the most difficult part of this is finding the center of pipes. And so what I would do now, if I were to draw this pipe from scratch, is I would make a center.
Draw a crosshatch?
Yeah, exactly.
Could you do that, like, you know how in IntelliCAD or DraftSite, how we have a layer that's not going to be seen?
You know, probably. And that's something
like
that...
Those little dash lines?
There probably is a way to do that, and that's a good idea. But I just haven't messed around with it to get to that level because I haven't needed to. But I bet you that is a viable solution. Oh, okay, so is there a flow arrow on it?
Oh yeah, those have to go the right way, huh?
Yeah.
Huh. Sure looks identical.
Right? Oops. Doesn't say it. I want to say it's going through this way, but
should be an arrow, right?
I would think so. How could you ask such a dumb question? That's what they're saying. I feel like I should know this, but it's like every time I'm like, I have to look at it. You know, it's just like, I probably could just look at one of my other drawings.
But I mean, as far as I could tell on that component, there's no discernible difference in the visual.
Well, so like the valve is sitting in there. If you put it on backwards, it won't do what it's supposed to do the way that it's like check valve. They're swing checks.
Mm-hmm.
And if you put it on backwards, it basically won't, you know, it'll stop. It'll only stop it in one direction. It would be the wrong direction.
It won't check.
Right. It would keep water from going into the system, right? Actually, now that I think about it, right? The system wouldn't even work.
Probably, right? The pressure, I don't understand exactly how the
water wouldn't be able to flow that direction through it because water can only flow one way through them.
But again, what I'm saying though, on the picture, if it looks no different when you turn it around.
Oh, no, it does.
It does.
Because this thing's only on one side.
Okay. Well, that picture, yeah, but the one we were looking at least from the back, you couldn't.
It had that as well.
Oh, okay. My bad.
Right here.
Oh, I see. Yeah, it's definitely offset.
Yeah.
When you turn it around, you can probably see that, okay, yeah, there's the 2 on the one side and the 1 on the other.
Mm-hmm.
So that has to be an indicator. The side that has 2 on
Oh, yeah, that's a good point.
versus the side that has 1.
Yeah.
What's going on here? Water's coming in one side.
Just like here and here.
Video.
For the ones searching for the products you need. Through 10-inch. Before beginning any work, familiarize yourself with these procedures to avoid harming yourself or damaging the assembly. A copy of the following procedures, as well as specification sheets, repair kit ordering information, and additional product resources.
I don't know if you saw that.
No, I was doing a little search of my own.
It gave us the answer, but it was an old cut sheet that I recognized from a long time ago.
Oh.
Shows it right there.
Yep. Okay, so the side with 2 is coming in. Side with 1's going out.
Yep.
That's actually was my thinking, but
yeah, I was too, but I don't really know why.
Well, my thinking was that when it goes out, the job's already done. When it comes in, it hasn't been checked yet, and the check system happens up front. But I don't know if that's good logic.
Works for me.
That was my thought process, and it happened to be correct. Might have been a coincidence.
Well, that kind of puts this. Okay, that's the right direction, but I need to turn this so the valves aren't against the wall.
Now, can its orientation be up and down versus, yeah, you can just rotate it?
Yeah, I think so. I mean, this can also, like, we put them going up and down all the time. That's not a problem too, but pretty sure that I should just, man, takes up way less space in here than it does on my other drawing, I think. This thing is like
making it 6 feet across.
Yeah, doesn't it seem like?
Yeah, but I mean, if you draw those so small, no one will be able to see them, right?
Yeah, I think that is why it's like that. Okay.
The symbols are so you can understand.
Yeah.
I guess otherwise you'd have to have a detail call out, right? With a smaller symbol. So those collars are called couplers, right? Coupling.
Couplings, yeah. Grooved couplings, or like Victaulic was like the first company that made them, and so a lot of guys in the trade just call them Vicks.
Oh, I see.
Something's not right here.
Doing that shaking thing.
Do that. I lost my coupling there. I thought
You need a couple of those couples.
Oops.
If only the installation was that easy, right?
Right.
For the guys watching. It probably will be in 20 years from now. Done.
Well, they supposedly want to make it so that you can wear VR gear, right? And just have a robot doing it or something. And
yeah. Probably not that far away from that.
You're just playing a video game or something.
Yep. Like right now you're actually doing it.
Yeah.
So it's this little dot on the line.
This doesn't look right.
Could be that one, right?
Yeah. Oh, I see what's going on. It's just throwing off my perception. Never mind. Okay.
That's a good fit.
Okay. So I also, something I need to think about is at some point in here I need to connect to a fire department connection.
FDC.
That's right. Gotta think about how I'm gonna run that. Okay, I know I can get rid of these. Oops.
Now we got those sleeves in the floor. Build them in. Like that.
I didn't actually have the floor trimmed out. I just had the sleeves sticking there, but you couldn't tell, so.
You couldn't sleeve them there.
Oh boy.
A little comedy for listeners, right? We gotta have the fun guy. Leave it alone.
You gotta introduce you to my friend Mike Platts, my structural engineer buddy.
He likes puns. I'm always like, yeah. There's always somebody who's like, oh yeah, you're a pun guy. You'll like this guy.
No, like I mean I like it too. I can't help myself, you know. The right situation, I'm the same way.
If I could get my mind to apply to other things the way I do puns, I'd probably be a wealthy man right now.
My oldest daughter, she was like a preteen. Somehow she got into like cheesy. Like I don't think I wasn't really ever into like telling dad jokes, but somehow she just got into like dad jokes, like cheesy jokes, you know. So I don't know, just always found funny ones and trade them back.
In my mind, you have the double check valve in place, and that existing assembly has one of those lines runs to the system in the building, and the other one runs to the fire department connection. Is that correct?
Well, the way this was to the underground, yeah. I'm gonna replace this T with a 90, so this will come into here, and I need to rotate this this T so that the feed is coming from this direction. And then I think what I'm going to do is just put a pipe coming straight up with this check valve on it to go to the FDC. I'm not going to actually pipe the FDC all the way to the first floor. I'm just going to end it right here and say to FDC.
Yeah. So you could pretty much just grab that one side on the right and just rotate it 90 degrees, right?
Which part?
The whole setup on the right there. The whole.
This?
Yeah, that whole setup, right? Isn't it just going to turn 90 degrees to be horizontal?
This T will. Let me see. I'm going to just start doing here what I'm thinking. Let's start on this side because this feels easier. I don't know why. Does that part make sense so far?
Yeah, I think so. You know what surprises me is that those look like kind of like short sweeps as opposed to long sweeps in plumbing. Is that a reasonable thing to say?
Yeah, long turn elbows and short turn elbows.
Does that
I don't
come into
really-
play on these?
No, it really doesn't. There's just one, really just one standard side. I mean, there are other types of elbows out there, but it's super rare for them to be used.
This is all iron pipe, right?
Yeah,
Like black iron?
yeah, like this is black, and then these are going to be, they're traditionally painted like red or orange for the fitting.
But it's that iron metal.
Yep, schedule 10. See, I'm going to want this the other way.
Is that a flow arrow on the side of that?
Yeah, this is a single check valve.
So aren't we flowing the other way?
No, you'll see.
Okay, I'm tripping.
It's because it's coming from the fire department connection, so we only want the water to be able to feed into the system.
I see. They're feeding more water into the sprinkler system.
Yeah, that's right.
But that is the supply on the right there coming in. I got
That's
it.
right. That's right. Okay, must be part of that.
So that explains to me why the backflow, double check happens over there on the right side. So if they're pumping water back in, it can't go back into the supply. It only goes to the building. Correct?
That's right. So we're getting there. We're pretty close to being done with the riser assembly.
Sweet.
So let's see.
Well, I think if we actually upload this video, this will be our best one with a lot of comedy in it.
That's what's important, right?
Hey, it could be,
Yeah, never
I
know.
was a bidder. I sure would appreciate that over somebody saying it really boringly. But this definitely shows, kind of the process of moving things around, selecting the side you want to work with. That little, whenever you're doing that, what do you call that one? The stretch, expand, push, pull.
Push pull?
Right?
Yeah.
And you select the side and you see those little dots. That shows he selected that side. And then he's
Right.
either making it stretch out or squish down.
Yeah, that's the
Little
surface
dot.
that I'm pushing and pulling.
The plane he's working with, you got to select that, and then you can
Yeah.
move it. And that whole process of trying to find the center of the circle, I mean, I could see someone getting frustrated for hours on that. And if
Yeah.
this video would be like, okay, I see. It is tricky, but there's a way to do it. Most of this stuff is usually like you haven't selected something and why it's not happening the way you want it to, right?
Right. It's important the sequence that you do things. Like for example, I could do the push-pull tool first before I select this,
Mm-hmm.
but it makes it's harder to pick the point that you want to push-pull from. Like it's just better if you select it and then push-pull. I can then click a base point to use.
Oh,
And
yeah.
sometimes like I want to do like a corner or something and follow a line.
Right.
At this point, I want to pull it, from the center, ideally, to where the other end of the pipe's supposed to go.
Makes sense. A little dot, not the deep one, but the X-ray.
Right.
Yeah, you're almost there.
Now, like, I guess I should be explaining stuff more as I'm going here, but like, to copy, you use the move command, but once you start moving, if you hit control, it changes it to copy.
And then you're going to ortho mode,
Yeah, this is rotate right here.
rotate.
I'm using the flat surface over here just to make it easy, because I wanted to rotate 180 degrees on that plane.
On that plane of, right, under the floor. The haunted coupling.
Oh, I should have done that, because I don't know if that's out. It's not lined with this.
So maybe you can just do a push-pull on the...
I can on this pipe, but I got to get these aligned first. So like, here, I'll do this.
Give yourself a guide.
Now, if I see how I'm on the red axis locked,
Yeah.
if I hold down shift, it gets thicker.
Uh-huh.
That means I'm actually locked onto it.
Goes like bold. Yeah.
Yeah.
Need an intersection.
Yeah, and so like you can't even tell that this isn't all the way in the right spot in the coupling, so I'm not even gonna mess with it.
It looks good, right?
Yeah, so let's see.
Got one of them pipe. It's like you have to ream it.
And I think if you accidentally get something else, it messes it up.
Oh, right. On the way.
Yeah.
Back to ortho mode. See what you're doing.
Oh, that's not quite lined up right.
Yeah.
I know what's going on.
You lined it up in the one direction, but not in the other, right?
Yeah.
If you'd tighten that all up in the real world, the boss would be mad.
You know, in the real world, there's probably enough flex in all of this.
Tweak it, yeah.
Yeah, across that distance to do that no problem.
Get the big guy to come and pull on the top section.
Yeah.
Together.
Still, oops, I don't know why I did that. No, there we go. This height probably isn't quite right. Oh, and I look at that. I accidentally stole the one off of there.
We ran out of couplings, boss.
Yeah.
What is it again? Once you start moving it,
Hit control.
Control, and then that duplicates.
And so, like there, I must have accidentally not hit control, or like if you hit control and then you have to go. Like I don't know if you've noticed. Like if I'm in push, pull, or move, and then I need to change the camera, I have to go into this other tool, right?
Orbit, which I keep on ortho.
Yeah, that's okay. Well, to get back into where you were and not lose it, you have to then click on the last tool you were using. And if you don't, you would just lose wherever you were in it. Does that make sense?
Yeah, it does. As long as you go directly to that next, it'll keep the, what do you call, consistency, or
like the active tool that you were in command or whatever.
The operation you were working on.
Yeah, exactly. I think that's good. We're a good stopping point.